Hello, today I am going to explain about difference between different types of microprocessors like 8086, 286, 386 and 486 microprocessors. My name is Suresh Bujja, Department of ECE. To watch more videos, please subscribe to my channel OpenBox Education. Let us see the difference between these processors. So the first one is that data bus. For 8086 microprocessor, it is a 16-bit size, and for 286 it is also a 16-bit size, and for 386 microprocessor and 486 microprocessor it is a 32-bit size, the data bus. And if you see the address bus, for 8086 microprocessor it is a 20-bit address bus, for 286 it is a 24, and for 386 and 486 microprocessor the address bus size is 32 bits. So here for 8086 and 286 microprocessors, the address and data lines are multiplexed, but for 386 and 486 microprocessors, the address and data lines are not multiplexed. And here the physical address size for 8086 microprocessor is 1 MB, and for 286 it is 16 MB, and for 386 microprocessor it is 4 GB of memory, and for 486 microprocessor it is also a 4 GB. And if you see the speed, so here for 8086 it is 8 MHz, and for 286 also it is 8 MHz, and for 386 it will be 50 MHz, and finally we have 486 is there, it has a 66 MHz speed. And the word size of 8086 microprocessor is 16 bit, and for 286 it is also a 16 bit, and for 386 and 486 it is of 32 bit. The math coprocessor for 8086 and 286 and 386 they are provided externally, and 486 microprocessor it has a inbuilt math coprocessor. So the math coprocessor for 86 is a 8087, for 286 it is 287, and for 386 it is a 80387. So these are provided externally. For 486 it is provided internally. And if you are going for the pins, number of pins for 8086 microprocessor, it is a 40 pin DIP, nothing but dual inline package, and for 286 it is a 68 pin and a flat package. And for 386 and 486 microprocessor it is a pin grid array package, and the number of pins for 386 is a 132, and for 486 it is 168. And if you see that execution speed of 8086 microprocessor, it is executes that instructions 2.5 million instructions per second, and for 286 it executes that instructions 8 millions instructions per second, and for 386 27 million instructions per second, and for 486 it executes that 54 million instructions per second. So this is the execution speed of that 86, 286, 386 and 486 microprocessors. And next one, the memory management. Here the memory management will be done externally for 8086, 286 and 386, but for 486 it is provided internally. And here the instruction cache only for 386 and 486 are there, they are provided externally. The instruction cache is 16 byte size for 386 microprocessor, and for 486 it is 32 bit size. And data cache, it is also for only 386 and 486 microprocessors. The data cache is provided 256 bytes externally for 386 microprocessor, and 8 KB bytes of size provided externally for 486 microprocessor. So this is about that instruction cache and data cache for 386 and 486 microprocessors. And coming to this flag registers, so for 8086 microprocessor we have total 9 flags are there. So those are overflow flag, direction flag, interrupt flag, trap flag, sign flag, zero flag, auxiliary carry flag, parity flag and carry flag. And for 286, with these 9 flags they are provided additionally 3 flags. Those are input output privilege level, so these are the 2 bits, and this is the NT, nothing but nested task. So 9 plus 3 here will get that 12 are the flag registers for 286 microprocessor. So here these input output privilege level bits and a nested task, these are the new for 286 microprocessor. And for 386, with these 12 flag registers they are provided additionally 2 for 386 microprocessor. Those are virtual mode flag and a resume flag. So here 12 plus 2, here will 14 for 386 microprocessor. And coming to this 486 microprocessor, they are provided additionally one flag, that is the alignment check for 486 microprocessor. So for 486 microprocessor, here we have total 15 flag registers will be there. And coming to the segments, here for 8086 microprocessor we have code segment, data segment, stack segment, and extra segments are there. And for 286 microprocessor is also same. And for 386 they are provided externally FS and GS segments. These are the two additional segments provided for 386 and 486. We can consider these segments are as a data segments. And next one is that offset registers. That is nothing but the offset address will be held by these registers. Those are SI, DI, and BX for 8086, and the same thing for 286 microprocessor also. And for 386 and 486 microprocessor, we can use any register to hold the offset address. And coming to that registers, these registers of size 8-bit or 16-bit size for 8086 microprocessor, and 286 microprocessor also the same size 8-bit or 16-bit. Those are accumulator, base register, count register, data register, source index, destination index, stack pointer, base pointer, and instruction pointer. These are same for 286 microprocessor also. But for 386 and 486 it is somewhat different. Those are the extended registers are. So these extended registers of size is 32-bit. So we can call it as a extended accumulator, extended base register, extended count register, extended data register, extended source index, destination index, stack pointer, extended base pointer, extended instruction pointer. Like this we can use for 386 and 486 microprocessor registers. And finally, this 8086 microprocessor is introduced in 1978, and 286 microprocessor introduced in 1982, and 386 microprocessor introduced in 1985, and 486 microprocessor is introduced in 1989. So let us we see that different types of packages what you are discussed in previous slides. So here we'll call this is a dual inline package. So this is the chip will be packaged in DIP. This is the physical view of the chip. And next one is that flat package. Here this is the chip used a flat package type. And finally we have a pin grid array type. This is the way of pin grid array. Thank you very much for watching this video. To watch more videos, please subscribe to my channel OpenBox Education. Thank you very much.